Hello everyone, welcome to my YouTube channel. Today we're going to discuss about the very important paper, which is paper 420620, May June 2023. And don't forget to subscribe my channel. So let's start from this paper. Now, this is question number 1, and this question is regarding the oxides from A to H. So answer the following questions about the oxides A to H. Each letter may be used once, more than once, or not at all. So a student will have to answer in the form of A to H. Don't write the name of the oxide. I'm also uh, going to tell you about some extra informations about this paper as well. Now, if we look at the oxides, you people should have the idea about the formula of the oxides. So let's start calcium oxide. So just stop the video and think about the formulas. Now, calcium oxide is CaO, aluminium oxide, this is Al2O3, silicon dioxide is SiO2, sulfur dioxide is SO2, this is carbon dioxide, this is iron 3 oxide, and this is silver oxide, and then carbon monoxide. And these are the extra information regarding the formula. So let's start from question number 1. Okay, the oxide which is responsible for the acid rain, there are two types of oxides which are responsible for the acid rain: sulfur dioxide and nitrogen dioxide. So just check your list: sulfur dioxide or nitrogen dioxide. So sulfur dioxide is D, so D is the answer. Has a giant covalent structure. There are different giant covalent structures, means silicon 4 oxide is also the giant covalent structure. Then diamond is also a giant covalent structure, and graphite is also the giant covalent structure. Just look at the key point and just think about your syllabus and find out the giant covalent structure. So silicon 4 oxide is there, so C is the answer. Then is a reducing agent in the blast furnace. So there are two types of reducing agent in the blast furnace: carbon monoxide and carbon. Carbon monoxide is the gaseous reducing agent and carbon is the solid reducing agent. So just look at the list. Carbon monoxide is there, so carbon monoxide is H, so H is the answer. Now, is the main constituents of uh, bauxite. Okay, the bauxite is actually used to extract aluminium metal in the chemical industry, and bauxite is aluminium oxide. Just look at the list. Aluminium oxide is B. So B is the answer. Now, is the main impurity in the iron ore? Iron ore is hematite. You know that this is Fe2O3. And the main impurity which is present in the hematite is the impurity of sand. And sand is silicon dioxide. So that's why the silicon dioxide is C. Silicon dioxide is a giant covalent structure as well as the impurity of hematite. The next part is can be reduced by heating with copper. So if some metal is reduced from its compound, it should be less reactive than the copper. So just look at the less reactive metal from copper, and you know that the silver, platinum, gold, they are below copper in the reactivity series. So that's why silver oxide is the answer, and silver oxide is at G. So G is the answer. Now, the second question is regarding the group 7 elements. State the name given to the group 7 elements. You know that the periodic table have different groups. Sometimes the group 1 alkali metals, group 2 alkaline earth metals, group 7 halogens, group 8 noble gases, and the elements which are at the middle of the periodic table, they are transition elements. So group 7 elements are halogen. Explain why group 7 elements have the similar chemical properties. So chemical properties are linked with the electrons in the outermost shell. As you know that all the elements are in group 7, so they all have 7 electrons in their outermost shell. So that's why they must have the same chemical properties. So the reason is same number of electrons in the outermost shell or in the valence shell. Okay. The next thing is you have to write down the color and state of group 7 elements. You know that group 7 elements that contains fluorine, chlorine, bromine, iodine, and astatine. So the first two elements are gases. They are the gases. Bromine is a liquid at room temperature, and the rest two elements are solids. The main feature of these elements is that they exist in the form of two atoms joined together or in the diatomic form. But here you have to write down the state at room temperature and pressure. Fluorine is a gas, so you can say this is a gas. Chlorine is also gas. Bromine is liquid. Now, if we look at the colors of these gases, fluorine is a greenish gas, or you can also say this is a light yellow or the pale yellow gas. Or you can say this is the pale green gas. Or you can also say this is the greenish yellow gas. Bromine is a red-brown liquid. Look at the next part. This part is regarding isotopes. State the term given to the numbers 79 and 81. Whenever the word isotope is there, you know that the isotopes are the atoms of an element. They have the same proton number but different nucleon number or different mass number. So this number 79 and 81, that is the nucleon number or mass number. So you can say nucleon number or mass number. Now, because they have the same number of electron, proton, and neutrons, so in the next part, you're going to calculate or you're going to find out the number of protons, neutrons, and electrons. Protons and the electrons, they are the same, but here you don't have the information about the proton number of the bromine. So just go in the periodic table and look at the proton number of bromine. So 35 is the proton number of bromine. So bromine, how many protons are there? 35. How many electrons are there? 35. Then 35 and then 35. Okay, students, you have to be careful while writing the number of electrons. Here is a mistake that if you look at the PR, this is not PR, this is PR negative. So that's why it has 36 electrons instead of 35. Now we can find out the number of neutron by subtracting the proton number from the nucleon number. So 79 minus 35, you will get 44, and 81 minus 35, you will get 46. So these are the number of electron, proton, and neutron in Br and Br negative. So Br, whenever there is a Br negative, you have one more electron as compared to Br. Then this question is regarding the relative atomic mass. So relative atomic mass can be calculated by using the relative abundance and isotopes, the mass of the isotope. So this is the formula that sum of the mass into abundance over total abundance. Now the bromine has two isotopes. The mass is 79 times 55. Then the second isotope is 81 times 45, and the total abundance is 100. So if you calculate this, you will get the answer up to the one decimal place, and that is 70. Let me calculate. Yeah, 79.9%. Okay, yeah, or you can say 79.9. Okay, now the next part is chlorine displaces bromine. So this question is regarding displacement reaction. As you know that the displacement depends upon the reactivity of the metal or the non-metal. So the reactivity of halogens, that decreases from top to bottom. You can say that the fluorine is more reactive than chlorine, and chlorine is more reactive than bromine, and so on. Now here, write a symbol equation for the reaction between chlorine and aqueous potassium bromide. Now, chlorine is a diatomic, then this is the aqueous potassium bromide. So chlorine is above bromine in the group. So chlorine is more reactive than bromine, so that's why it can displace bromine. If it displaces, we will get the potassium chloride plus bromine. Then you have to balance the chemical equation. There are two chlorine atoms. So if you put two here, two potassium, two, and bromine is already balanced. State why chlorine does not displace fluorine from the aqueous solution of sodium fluoride. As I have already mentioned that the reactivity that decreases from top to bottom. So chlorine is less reactive than fluorine. So that's why it cannot displace the fluorine from its aqueous solution. We can say that chlorine is less reactive than fluorine. Or you can say that fluorine is more reactive than chlorine as well. Now, there is another question. Aqueous silver nitrate is a colorless solution containing Ag positive ions. Describe what is seen when aqueous silver nitrate is added to the aqueous sodium chloride. Now, this is regarding the test for anions. Whenever you have the chloride, bromide, or iodide ion, so aqueous silver nitrate is used to test these ions. So, aqueous silver nitrate, when it is added to the aqueous chloride, you will get the white precipitate. In the case of bromide, green precipitates. In iodide, yellow precipitates. So aqueous silver nitrate is used to test the presence of chloride, bromide, or iodide in aqueous solution. Then the formula of these precipitate, this is silver chloride, this is silver bromide, and this is silver iodide. So these are the precipitate. So if you want to write down the ionic equation for the precipitate, just copy the precipitate on the right hand side, because this is the ionic equation for the reaction between aqueous silver nitrate and aqueous sodium chloride. Although the complete reaction is different, but if you want to write down the precipitate, just write the precipitate on the right hand side and the two aqueous forms of that precipitate on the left hand side. So this is the ionic equation of precipitation for silver chloride. Now describe what is seen when aqueous silver nitrate is added to the aqueous sodium chloride. As I have already mentioned, that you will see the white precipitate. So here you will see the white precipitate. If you have the bromidine, you will see the green precipitate, and in the case of iodide, you will see the yellow precipitate. Now, look at the next one. Okay, this question is over 200 million tons of the sulfuric acid are manufactured every year. State the name of the process used to manufacture sulfuric acid. You know that there are two processes in the chapter equilibria. One is the Haber process that is used to get ammonia in the industry, and the second is the contact process used to get sulfuric acid in the industry. So this is contact process. Now, two methods by which sulfur dioxide is obtained. This is a direct question in your specification or in your syllabus. You know that by burning the sulfur in air, you will get the sulfur dioxide. So burning sulfur in air, you will get the sulfur dioxide. You know that when sulfur is burnt in the presence of oxygen, you will get sulfur dioxide. And the second thing is roasting sulfide ore. Roasting sulfide ore. Sulfide ore in air. Generally, the iron pyrite is used, FeS2, that is used to get Fe2O3 plus sulfur dioxide, and then we have to balance this equation. So these are the two methods which are used to get sulfur dioxide in chemical industry, either by burning the sulfur in the air or by roasting iron pyrite, which is the sulfide ore in the air. Now, this is regarding the reversible reaction. As you can see that the reversible reaction is there. So state two features of an equilibrium. Reversible reaction is the reaction in which the two-way traffic is there. The reactants react to form products, and product can reform the reactant. And during the reversible reaction, this is a state of a reversible reaction when the rate of forward reaction that exactly equals to rate of reverse reaction. So this is the feature of the reversible reaction or the state equilibrium. So at equilibrium, the rate of forward reaction is equal to the reverse reaction. And at this stage, the concentration of both reactants and the product that becomes constant. Reactants and the products are constant. Now, there are some typical conditions used to get sulfur trioxide, and then it is followed to get sulfuric acid. So the temperature, it must be 450 degrees Celsius. The pressure 1 to 2 atmospheric pressure, or in kPa, you can say 100 to 200 kPa pressure. And the catalyst is vanadium pentaoxide. You can say vanadium pentaoxide or vanadium 5 oxide. 5 is the oxidation state of vanadium 5 oxide, and the formula is V2O5. So these are some specific conditions used to get sulfur trioxide, and then sulfur trioxide is followed to get sulfuric acid in the chemical industry. So this is another question. I mean, now you'll have to explain in the terms of shifting of equilibria and the rate of reaction. Now, the forward reaction is exothermic. So this is exothermic reaction. It means that the reverse reaction is endothermic. And if the overall reaction is, if the forward reaction is exothermic, the overall reaction is also exothermic. Now you have to answer in the terms of that only use the words increases, decreases, or no change. Effect on the rate of reaction. So be careful. Now this is the rate of the reaction. An effect on the concentration of the sulfur trioxide. So in the second part, you have to explain in the terms of shifting of equilibria. And in the first part, just talk about the rate, whether the rate increases, decreases, or no change. So pressure increases. When the pressure increases, you know that the particles, they come close to each other, then the volume will decrease, and there must be more effective colan. So if you increase the pressure, definitely the rate of reaction will also increase. Now, this is about the shifting of equilibria, because this is equilibria. Okay, so when equilibria shifts, either it shifts from left to right or from right to left, then you can decide about the concentration of sulfur trioxide in the equilibrium mixture. Now, if the temperature is decreased, if the temperature decreases as the forward reaction is exothermic, so that's why the decrease in temperature will favor the forward reaction. Decrease in temperature will favor the forward reaction, as the forward reaction proceeds by releasing heat. So if you decrease the temperature, the equilibrium shifts to right. So if equilibrium shifts to right, definitely the yield of sulfur trioxide will increase. So the amount of the sulfur dioxide or the concentration of the sulfur trioxide in the equilibrium mixture increases. Then pressure increases. If pressure is considered, then just look at the number of moles of the reactants in the product. Okay, but keep in your mind that the pressure is only affected on the gases. So look at the number of moles of the gases. So there are 3 moles on the left hand side and 2 moles on the right hand side. Whenever the pressure is increased, the equilibrium shifts from more moles to less mole. So more moles on the left hand side. So that's why equilibrium shifts to right, and that increases the concentration of sulfur trioxide in the equilibrium mixture. Okay, when no catalyst. Catalyst doesn't affect on the position of equilibrium, so that's why no change. There must be a no change. Move to the next part. Now, there is a Colan theory which explains the rate of the reaction. Now, explain that in the terms of Colan theory, why reducing the temperature decreases the rate of the forward reaction. Now, he's reducing the temperature. Generally, the examiner asks about the increase in the temperature. And when we say that increase in the temperature, that increases the kinetic energy of the particles, that will cause the more frequent collisions per second, or the frequency of the collision that increases. Now, more particles have energy equal to or more than activation energy. So we'll have to write down the effect by reducing the temperature. So if the temperature is reduced, definitely the kinetic energy of the particle will also decrease. So the first point is regarding the kinetic energy of particles. So kinetic energy of particles that decreases. Now frequency of effective collisions that will also increase, that will also decrease because he's reducing the temperature. So frequency of effective collisions decreases as he's reducing the temperature. Then now you have the lower percentage or less, there are less particles have energy equal to or more than activation energy. So that's why if you have the less proportion or less number of the particles which have the energy equal to or more than activation energy, so that's why you can say that the rate of the reaction decreases. So these 3 points are there, and the examiner had already told us that decreases the rate of the reaction. So no need to write down or no need to copy this statement. Now, this question is regarding oxidation number. Now, this is a yne, so the sum of oxidation states of sulfur and oxygen will not be equal to 0. That will be equal to -2. So there is 1 sulfur, 4 oxygen, and the difference is -2. As you know that the oxidation state of oxygen is -2. Normally it is -2, sometimes -1, but that is not in this case. So this is the solution. So sulfur -8 is equal to -2, and sulfur is -2 plus 8, which is +6. So the oxidation state of sulfur in sulfate is +6. Then move to the next part. State what is meant by the term base. So acid and bases, they can be defined in the terms of either the proton donor or proton acceptor. So acid is a proton donor, base is a proton acceptor. So you can say that base is a proton acceptor. State the term given to the base which dissolves to form aqueous solution. You know that the highly soluble bases, they are alkalis. So that's why this is alkali. You will have to use the term only. Okay. Then state the color of this indicator in the aqueous sodium hydroxide. There are different indicators in the your syllabus like phenolphthalein, methyl orange. Okay, so this indicator is a blue. Complete the word equation. So he's saying that complete the word equation. Don't write the symbol equation. Sodium hydroxide and ammonium chloride. You know that whenever the base, if it reacts with the ammonium salts, you will always get another salt, then ammonia, salt, ammonia, and water. So these are the 3 products which you may get by reacting any base with the ammonium salt. Now, ammonia is here you can write the ammonia. Here you can write the water. And the salt which you may get, the first part of this and the second part of this compound, that is the sodium chloride. So here you can write the sodium chloride. There are 2 lines. So in the first line you can write sodium, and the second line you can write chloride. There are not 4 products, there are 3 products. Now, The next part is some metal oxides react with the sodium hydroxide. Now, you know that the sodium hydroxide is also base, and metal oxide, they are also basic. Okay, they are also basic. Not all the metal oxides, they are basic, but group 1, 2, and copper and iron oxide, they are basic. But if you take the example of aluminium oxide, okay, aluminium oxide, that is not basic, that is amphoteric. So generally we think that the basic oxides cannot react with the base. Yes, they can't react with the base, but some metal oxides are amphoteric as well. So state the term given to the metal oxide which react with the base such as sodium hydroxide. So if a base react, if the metal oxide, if it reacts with the basic substance, it should not be a basic. It should be acidic. But here he is saying that metal oxide. So metal oxides are basic. So it means that we have to use the amphoteric oxide. So amphoteric oxide generally react with the base. Name a metal oxide which reacts with sodium hydroxide. So here you'll have to specify the amphoteric oxide. So aluminium oxide can react, or there is another amphoteric oxide. You may write aluminium oxide or zinc oxide. So these are the two amphoteric oxides. They can react with the base to form salt and water. So this is the dot and cross diagram of the ethanoic acid. So if you want to make the dot and cross diagram of ethanoic acid, that is very simple. Carbon has 4 electrons in the outermost shell. So the electrons of carbon, they are shown with the dots. So if it has 4 electrons, so 1, 2, 3, and then 4. This hydrogen has, every hydrogen has 1 electron, but first of all, fix the electrons of carbon. Here, you know that this part is like this. There is a double covalent bond between carbon and oxygen, and then single covalent bond. So here you have the double covalent bond. Now, this carbon can make 4 covalent bond if it makes one bond with this carbon and one bond with this oxygen. Then there are 2 electrons, O1, 2. They can make double covalent bond with this oxygen. Okay, so here the double covalent bond with this oxygen. Now, there is a single covalent bond between carbon and oxygen, so you can draw a single covalent bond. So every hydrogen has 1 electron, so 1 electron, 1 electron, 1 electron. Here you have 1 electron, 1 electron of oxygen is busy with this hydrogen. Oxygen has 6 electrons in the outermost shell, 2 are busy, but don't forget to draw the rest of the 4 electrons in this oxygen as well as in this oxygen. So 2 electrons are busy, so the 4 electrons, they must be drawn. So this is the dot and cross diagram of ethanoic acid. Suggest the pH of the dilute ethanoic acid. As you know that the ethanoic acid is a weak acid, so you can write the pH, it must be like 3 to 4 or less than 7. Now, there is a dissociation of ethanoic acid. Ethanoic acid is a weak acid. So whenever you have a weak acid, and if you want to dissociate it, you must show the sign of reversibility. So here you can show the sign of reversibility, and acid is a proton donor. So if you remove this proton as a H positive, you will get a CH3COO negative, which is ethanoetine. So if you add these two ions, we'll get CH3COOH. Write the ionic equation for the reaction when an acid neutralizes soluble bases. Actually, whenever you have any acid, like if you have acid HCl, if it reacts with the sodium hydroxide, you will get two products, sodium chloride plus H2O. So you can skip the spectator ions. Na positive are spectator ions, then Cl negative are spectator ions, and you will get the ionic equation of neutralization. So this is the ionic equation of neutralization: aqueous H positive, aqueous OH negative, and liquid water. When you skip the spectator ions, you will get the ionic equation of neutralization. Here we have another question which is regarding to number of moles. We have the data regarding the titration, 25 centimeter cube. Here we have, okay, 25 centimeter cube of 0.80 mole per dm cube aqueous potassium hydroxide is neutralized by 20 centimeter cube of dilute sulfuric acid. So this is the reaction between these two compounds as well. Calculate the number of moles in potassium hydroxide. So if you want to calculate the number of moles in potassium hydroxide, the concentration is there, the volume is there. So the formula is C times V by 1000, 0.0800 times 25 by 1000. So if you multiply this, you will get 0.002. Determine the number of moles of sulfuric acid. Now you can use the stoichiometry. Sometimes the students use the molar gas volume concept and they will start dividing 20 by 24,000 to get moles. This is not the way. This is not the gas. This is aqueous solution. So you'll have to use the stoichiometry concept to get the moles of sulfuric acid. As you can see that this reaction is between potassium hydroxide and sulfuric acid in 2:1. So the moles of sulfuric acid, they are half as compared to the moles of potassium hydroxide. So if you want to get the moles of sulfuric acid, just make it half. Okay, so you will get the moles of sulfuric acid. Then calculate the concentration of sulfuric acid. So whenever you want to calculate the concentration, you can use the same formula like N is C times V by 1000. So this volume must be in centimeter cube. If you want to get the concentration, you can rearrange this formula N times 1000 by V. So then you know the number of moles 0.001, then 1000, and the volume is given. You have, I think, yeah, 20 centimeter cube of sulfuric acid. So if you put 2 here, you will get the answer, and that answer is 0.05. Now, this is the concentration in moles per dm cube. So if you want to convert in grams per dm cube, so the concentration in moles per dm cube is equal to, sorry, the concentration in grams per dm cube, because we're going to convert in grams per dm cube. So the concentration in moles per dm cube multiplied by mr. So the mr of this compound is 2 plus 32 plus 64, which is 98. So you have the answer 0.05, which is the concentration in moles per dm cube. Just multiplied with 98, you will get the answer, which is 4.9 grams per dm cube. So this is the way to get the answer. But if you people are using the same data to calculate the concentration, so first of all, you can calculate the concentration in moles per dm cube. You can use this formula C1V1 over N1 is equal to C2V2 over N2. This is especially for MCQs. If you have the same data, you can use this formula to get the answer. Number of moles from equation, C is the concentration, V is the volume. So if you want to calculate the concentration of any substance, like if you want to calculate the concentration of sulfuric acid, just think about that this is C2, put the concentration of base, then volume of base, number of moles of base from the equation. This is question mark, this is I think 20, this is 1, number of moles of base are 2, and then V1 is 25, and this is I think 0.08. So if you put the data 0.08 times 25 and the number of moles of base, you can see number of moles are 2. 2 is equal to, now you are going to calculate the C2, V2 is 20, and the number of moles of 1. So if you calculate, you will get the same answer, 0.05, which is the concentration in moles per dm cube. So this is the best way to get the answer for MCQs especially. I hope you will get the answer. Then this question is regarding organic chemistry. Now propane and propene both react with the chlorine. You know, propane is the Propane and propene both are hydrocarbons. So propane is C3H8 and propene is C3H6. Propane, the general formula of alkane is CnH2n plus 2, whereas the general formula of alkene is CnH2n. So just think about this. Both react with the chlorine. You know that whenever the alkane react with the chlorine, the substitution reaction will take place, and alkene can react with the chlorine by the addition reaction. So just think about these two topics, and you can answer these questions. So when a molecule of propane reacts with the chlorine in the presence of UV light, so this is ultraviolet light, what will happen? One atom of hydrogen is replaced by the one atom of chlorine. So this replacement, that is a substitution reaction. So just write down the term. The term is substitution reaction. So this is substitution. State the purpose of the ultraviolet light or UV light. Actually, this UV light helps to break the single covalent bond between chlorine and chlorine. So to break the single covalent bond between chlorine and chlorine, you can write this, or you can write this that it actually provides the necessary activation energy. Provides activation energy to start reaction or energy needed to break bond. State the term given to any reaction which requires ultraviolet light. You know that the photosynthesis is the type of reaction which also requires the UV light. Write a symbol equation for the reaction between propane and chlorine. So symbol equation, you know that the propane is C3H8, chlorine is Cl2. So if we replace just one hydrogen, we will get a C3H7Cl plus HCl. So this is the equation for the substitution reaction of propane with chlorine. A molecule of propene, you know that this is the unsaturated state. Why propene is an unsaturated molecule. Unsaturated is that it contains double covalent bond between carbon to carbon. Between carbon to carbon. So if there is a double covalent bond, that is unsaturated, and single covalent bond saturated. Give the structural formula of the product of this reaction. This reaction is between propene and then chlorine. So you know that the propene is like this, CH3, CH double bond, CH2. So if it reacts with the chlorine, double bond must be broken. So you can break the double bond. You can remove this double bond. So if you remove this double bond, okay, if you remove this double bond, you can add one chlorine with this carbon and one second chlorine with this carbon, one chlorine with this, one chlorine with this. So you will get a structure like CH3, CHCl, and again CH2Cl. Okay, the next part is propene undergoes addition reaction with steam. Here, if you have the propene, like this was the propene, let me rub this. So if you have a propene, this is the propene, and if it reacts with the steam is like this. So you will have to add HOH bond, HOH, two groups in this propene. If you break this bond from here, and then just remove the second bond from here, if you add H here, you will get CH2, and OH here, you will get one product. And if you add OH here, like if OH here, and then H here, you will get like this. So it may be the name of the product. If the first product is propane 1-ol, so you may get propane 1-ol or propane 2-ol. So this is prop one ol, and the second product is propane 2 ol, propane 2 ol, propane 2 ol. Then you can draw the displayed formula. This is prop, then OH, and then you can draw the rest of the hydrogen. Here you can draw the rest of the hydrogen. This is propane 1 ol, and the propane 2 ol, it should be like this, because the OH group, it must be on the second carbon. Then, okay, this is the question regarding alkene and chlorine, and alkane and chlorine. Now, the next part is carboxylic acid can be converted into ester. So, carboxylic acid is converted into ester, and you know that carboxylic acid, when it reacts with the alcohol, you will get the esters. Name the ester formed when butanoic acid. If you want to write down the name of the ester from carboxylic acid and alcohol, just pick the code letter for the alkyl, uh, al- alcohol as a alkyl, like this code letter is eth, make it ethyl. And let's pick the code letter for the acid, which is butano, and just add another suffix 8. So this is ethyl butanoate. If you have butanol and ethanoic acid, you may get butyl ethanoate. So this is ethyl butanoate. This part is from alcohol, and this part is from carboxylic acid. I hope you get the answer. Identify the other product formed in this reaction. You know that the OH from this and H from this, you will get another product, which is water. Deduce the empirical formula of the ester formed. We just count that how many carbon atoms are there. 1, 2, 3, 4, 5, 6. You have 6 carbon, okay, and the general formula for the ester and carboxylic acid is CnH2nO2. If you have 6 carbon, hydrogen must be 12 and oxygen are 2. So C6H12O2 is the molecular formula. So if you simplify this formula, you will get 1, 6, and 3. So C3H6O, that is the empirical formula. He's not talking about the molecular formula. He's talking about the empirical formula. So this is the simplest formula or the empirical formula. This is a polyester circle 1 repeat unit of this. Okay, so this is the repeat unit. Then draw the structure of the monomers which make up this. Okay, so there are 2 monomers which are required to make this ester. One is, this is the first monomer, and this is the second monomer. And you can draw like this. So just copy the half part from the polymer. Okay, and okay. Now you can put OH in to make it carboxylic acid and just H to make alcohol. So these are the 2 monomers which are required to make this polymer. Draw the structures of the monomers which make this, and draw the functional group using displayed formula. So these are the functional group. This is the alcohol, this is the carboxylic acid. Then state the type of polymerization. You know that when alcohol and carboxylic acid, they react with each other, you will get the ester and the water. So the addition of two monomers to form polymer by the eliminating small amount of water and acid, that is condensation polymerization. So this is the condensation polymerization. This is all about for today's class. I hope you will get the answers, and I think you have enjoyed this class. If you want to solve any specific paper, let me know, then I will solve for you. And don't forget to subscribe my channel. Thank you.